able to calculate the density of a grape. So, to determine the density of a grape, we will exhibit the upward buoyant force of the grape in water, and this will directly demonstrate Archimedes' principle, which is what this experiment is about. So the learning goals is to be able to demonstrate Archimedes' principle, which is defined as the upward buoyant force exerted on a body in fluid, whether fully or partially submerged, is equal to the weight of the fluid that the body displaces and acts in the upward direction at the center of the mass of the displaced fluid. So, the equipment we will be using to demonstrate this is a 100 milliliter graduated cylinder. We will be using 3 grapes, a digital scale, and the procedure is as follows. We will measure the mass of the grape. We will place the grape in around 50 milliliters of DiH2O in a graduated cylinder, and then we will observe the water displacement in the cylinder in milliliters. And then using the equation density is equal to mass over volume, we will be able to determine the density of the grape. And this will be done 3 times in order to get an average density. So we will have 3 trials.
Alrighty, so to begin with, for our key formulas, we're going to be using the FB equals FG formula, and FB equals buoyant force, and FG equals the force of gravity. And then we're going to use the density equals mass divided by volume, and then for finally we'll use force equals mass times acceleration. Okay, so first we're going to weigh grape 1. And grape 1 is 7.579 grams. And now, we're going to go over here and drop it into 50 milliliters of water. And it raised to 58 milliliters of water.
So here we have all of the data for grapes 1, 2, and 3. So we have the weight that we calculated using our digital gram scale, and then we have the volume, which was calculated by observing at eye level the water displacement in milliliters once we put the grape in a graduated cylinder. So we take those values and we put them into the density equation of mass divided by volume to get a density for grapes 1, 2, and 3. And then we take all the densities and we divide it by 3 to get an average. And then we conclude that the density of a grape is 0.832 grams per milliliter to answer the question to our experiment.
So, when calculating buoyancy, the equation is FB equals FG. Force of buoyancy equals force of gravity. We also know that force equals mass times acceleration. Acceleration here would be gravity. So, taking grape number 1, for example, the mass is 7.580 grams, which translates to 0.00758 kilograms, and the water displaced, the volume, was 8 milliliters, which converts to 0.008 kilograms through stoichiometry. So, when calculating this buoyant force of the grape, I start off here with Fg. We take the mass of the grape, 0.00758 kilograms, multiplied by the acceleration of gravity, 9.81 meters per second squared, gives us 0.074284 newtons. When calculating the buoyant force of the grape, we take the volume of the water displaced, which was 8 milliliters, which converts to 0.008 kilograms, multiplied by 9.81 meters per second squared, which is the acceleration, which is the force of gravity, which gets us 0.0784 newtons. Therefore, the buoyant force, which is 0.00784, is greater than the force of gravity, 0.074284. And therefore, the grape should float because the buoyant force is greater than that of gravity. The ability of an object to float is described as its buoyancy. The buoyancy of an object is a tendency to float on or rise in a liquid. An object that floats in a liquid is said to be positively buoyant. An object that sinks in a liquid is said to be negatively buoyant. To determine an object's buoyancy, both mass and volume must be taken into consideration. In order to explain how an object's density influences its buoyancy, the behavior of an object placed in water must be understood. When an object is placed in water, even a floating object displaces a little bit of water. The amount of water displaced is a function of the object's mass. The object sinks into the water until it displaces an amount of water equal to its own mass. This means whether or not an object will float or sink, it depends on its own density and the density of the liquid it's placed in. Another way to look at the buoyancy of an object is the interaction of two forces. The force of gravity, Fg, pulling down on an object. This is the weight of the object. Its mass times the acceleration due to gravity, 9.81 meters per second squared. It is the force expressed in newtons. The second way to look at it is the buoyant force, which is Fb. So the buoyant force is the force that holds the object up. This can be measured as the force of gravity acting on a mass of water equal to the amount of water the object displaces when fully immersed.